Hi dear students, welcome to our lecture 4. This is the last lecture in this video lecture series on module 5. Okay, and this is the last topic in module 5. So in this lecture video, we'll be mainly dealing with the design of chain drives. So we have already finished the design for design procedure of flat belt, design procedure of V belt, and now this is the last type of transmission system which is there as per your syllabus. Okay, and in this design video we'll be covering entirely on the design procedure of design of chain drives. Okay, so from the figure itself it is very pretty much clear that what a chain drive is, right? So you might have already seen this in your bicycles and your motorcycles and all. This type of system is very common, right? It is also used in different other applications as well. Okay, so in this lecture video we'll be seeing how it is designed. So what are the basic or the standard procedure using which you can design this chain drive. Okay, now as I used to say, before going to the design procedure, there are actually basic design parameters that you need to find. Okay, now designing actually means to find out the basic dimensions of that of whatever component you are designing. With respect to a particular application, right? So there are basically some basic dimensional parameters that you are going to find at the end, right? So let us see what are those parameters, and based on which we'll be learning the procedure. Okay, so the basic design parameters as far as your chain drive is concerned are, now before going to that, let us see what are the basic parts of a chain drive. Okay, so as you can see, for a simple chain drive you can see two sprockets are there, right? One is a smaller sprocket and the other one is a larger sprocket, and this and a complete chain is attached with this one, right, in the form of different chain links, right? And these links are held together using hinges, right? Okay, so this is the basic construction. So the basic things that or the basic dimensions that we are going to design and using this design procedure are, the first one, or the first and the important one is to find the chain pitch. Okay, the distance between the hinge points, center points of the hinges, or the basic pitch. Okay, chain pitch you need to find, right? And the second most important thing is the type of chain, right? There's the type of chain. There are different types of chain depending upon the different application or different type of power transmission. You need to select a particular chain. We'll see that while we are solving a problem. Okay, how a type of chain is being selected using the manufacturer's catalog. Okay, now after this you need to find the total length of the chain. Okay, so that is very important because the chain must be accurate, so that then only that proper transmission will happen. Okay, if it is more and if it is less means the connection it will not be proper, and if it is more means the more sagging will happen at the top end and the proper transmission will not happen, and the chain that will not be held tightly, right? So total length, accurate length is also very much important. Okay, and finally you need to find the pitch circle diameter as well as the outer diameter for the sprocket. Okay, so these four are the basic parameters which we are going to find. To find these basic parameters, we will be going through a number of series of steps to find out all these parameters. So what are those steps? Okay, so let us start our journey on design procedure. Okay, first of all we'll be seeing the design procedure, after which we'll be solving a problem, right? So we'll be solving the problem using the data book itself. Okay, now the basic design procedure starts with determining or selecting a preferred transmission ratio. Okay, now there are two terms over here. You can see is to determine or you can select. Okay, you can either determine or you can select a preferred transmission ratio. Okay, now if in the question if your RPMs are given, okay, RPM of the smallest sprocket as well as RPM of the largest sprocket is given. If it is given means you can directly find the transmission ratio using the ratio of n1 by 2. Now if suppose it is not given, you need to select the transmission ratio. For that you can make use of the data book page number 7.74. Okay, so depending upon certain condition you can directly select the transmission ratio. We'll see that when we are solving the problem. The second step is to select the number of teeth on the pinion sprocket. Okay, and that is selected, and you may select that, and that directly depends upon the transmission ratio. with respect to that range, we'll be selecting the number of teeth on the pineum. Okay, so once that is found, your number of teeth on the other sprocket can be easily found out using the relationship Z2 is equal to I Z1. Right. But now, if suppose you are not, you don't remember this equation, you can find the equation also in page number 7.74. Okay. Now, once that Z2 is found out, it must satisfy a particular relation. That is, your Z2 must be less than Z2 max. Okay. So there is a maximum limit for the number of teeth for a chain sprocket. Okay. And that is given in your data book. You can find page number 7.74. Once you have found that Z2, you need to check with the maximum value. And if it is less only, the design is safe to proceed. Otherwise, you need to select a value in between, within the range of that maximum Z2 value. Okay, and you need to recalculate Z1 and then proceed. Okay, right. So the next procedure, now the next step is to determine the range of chain pitch, or to find the maximum pitch or the minimum pitch. Okay. Now for that you can use the optimal center distance formula. That center distance is given by can be taken in anywhere in between 30 to 50 p. Okay. Now if you equate the center distance, if it is given center distance with 30 p, you will be getting a minimum pitch value, and if you equate A with 50 p, you will get a maximum. Sorry, you will get a minimum pitch value if you equate with 50 p, and when you equate with 30 p, you will be getting a maximum pitch value. Okay, so you will get a range of pitch value, out of which you can select any of the value depending upon the condition. Okay, we'll see that in detail. Right. Now once so your one of the first objective has been found out. Okay, so we have completed the pitch for the first objective. Yes, it's check. Right. Now, once this is done, you need to select a type of chain. Okay, you can either select a simplex or duplex. There are also triplex chains. Okay, now for the time being, as per the design procedure, you need to select a simplex or a duplex chain. Okay, now for that there is a table, there is a standard table, and we'll see that while we are solving the problem. Okay, now based on that, we will be selecting the duplex. Based on the pitch value, we'll be selecting a type of chain. Okay, so once we select that value, we'll be finding the total load, which is the sixth step, total load on the driving side of the chain. Okay, total load which is acting on the driving side of the chain will be found out. Okay, now you can find that using the equation given in page number 7.78, and the equation is nothing but you need to sum these three values. Okay, small pt, pc, centrifugal force, and PS. Okay, we'll see what are those values. Right. Now, once the total load has been found out, once the total load is found out, the next step is to calculate the design load. And mind you, this equation is not there in the data book. The total load is given by PT into KS. Okay, so you need to multiply the total load value which we got in sixth step with a constant. Okay, and that Ks is actually a product of these many constants, that is constants K1, K2, K3, K4 and K5. So to determine all these constants, you can get those constant values from page number 7.76 and 7.77. Okay, so once you find all those values, you need to substitute the value over here and find the design load. Okay, so once you get the design load, the next step is actually to find the factor of safety. Okay, so for that we will be dividing the total load value, sorry, with the rated value with the sum of the loads. Okay, so all those things we will see in detail while we are doing the problem. Okay, alright, so after finding the factor of safety, we'll check the bearing stress or the induced stress using this standard equation. And again, this equation is also not there in your data book. Why? By multiplying PT, which is the subscript is small t, into Ks divided by area A, and that area value, the area is the bearing area, and that bearing area you can get it from standard table in your data book. Okay, so after getting this induced stress, we will be checking whether the stress is safe or the design is safe by comparing it with the standard stress value based on a standard table. Okay, so this is your eighth step. Once the eighth step is completed, we will find the length of the chain using the equation given in page number 7.75. And once the length is found out, which is your next objective. Okay, the last objective is to find the pitch circle diameter and the outside diameter of the sprocket, and for that you'll get the equation in page number 7.4 and 7.8. Okay, so these are the basic or the standard procedure. Okay, so all these things we are doing all these 10 steps to find those 4 parameters. Okay, now let us see in detail how this is done. Okay, so I know it is very difficult to remember all these things step by step, so and without seeing the data book pages, right? So we'll see how it is done using this particular problem. Okay, see now, let us see the problem. Okay, now the problem is about to design a chain drive to run a compressor from 11 kilowatt electric motor running at 970 rpm, the compressor speed being 330 rpm. The compressor operates 16 hours per day. The center distance should be approximately 500 mm. The chain tension can be adjusted by shifting the motor on slides. Okay, so this is a question. Okay, now you are asked to find or to design a chain drive. Okay, to run a compressor from 11 kilowatt electric motor. So the first thing and the best thing is just make it a rough sketch of that question. Okay, so you can see now this is your motor and this is your compressor. Okay, now it is transmitting a load of 11 kilowatt, right? Motor is running with a power of 11 kilowatt and it is running at 970 rpm. As you can see, I have already marked that value, right? Now it is making the compressor to run at an rpm of 330 rpm. Alright, the diameter and other things are not there. You need to find all other values, right? And the center distance is also given. It is 500 mm, right? Okay, so with this available data, let us start the design procedure. Okay, now the first step, as I said, is to determine the transmission ratio. Since here the RPMs are given, N1 is given and N2 is given, you can directly find the transmission ratio. Okay, so here we are actually determining the transmission ratio rather than selecting the transmission ratio. Okay, so the transmission ratio is equal to N1 by N2, and on solving that you will get the value as 2.94. Okay, it is close to 3, right? Okay, now to see, let us go to page number. This equation you can find it from page number 7.74. Let us see how the page data book page looks like. Okay, so if you go to page number 7.74, you can see a page something like this. Your transmission ratio, the equation is given, Z2 by Z1 is equal to N1 by N2. Okay, now if suppose your transmission ratio is not given, you can select any preferred transmission ratio from here. Okay, these are the preferred transmission ratios. You can take 1, 1.12, 1.25, 1.4, 1.6, any of the values. Okay, and you need to check everything, and if the stresses and all are within the limits, means your design is safe. If not, you need to redesign. Okay, so in mostly there's that rpm or something will be given so as to find the transmission ratio. Okay, fine. Now this is your page number 7.74, right? Okay, now once your transmission ratio has been found out, the next step, as I said, is to find, yes, you are correct, it is to find the number of teeth on the driver sprocket. Again, for that also you need to go to page number 7.74 only. You can see the table over here. Okay, recommended value for Z1. Okay, so the transmission ratios range is given over here, and based on that range you can select the number of teeth on the sprocket. Okay, now if you remember, the value for I was found to be 2.9 something, right, which was close to 3, right? So you can take any value between 25 and 27. Okay, any value between these two. Okay, so let us select the value 25 for the time being. Okay, any value you can either take 25, 26 or 27. Okay, now let us take 25 for our problem. Okay, now if you take 25 as the number of teeth, Z1 as 25, then the number of teeth Z2 will be equal to IZ1, which is nothing but 74. Okay, now you need to check whether it exceeds that set max value or not. Okay, so let us go and check whether it exceeds the set max value. You can see the set max value, the range should be between 100 to it should maximum value is between 100 and to 120. Okay, so the value which we are getting is 74, which is less than 100, so the value is safe. Okay, so you can take that value itself. Suppose the set2 value is satisfactory, you can continue to the next step. Okay, so till now we have found out the number of teeth. See, we have already found out the transmission ratio and number of teeth. That's it. Okay, now let us try to find out the optimum. Now using the optimum center distance equation, let us try to find out the pitch. Okay, as I said, pitch is one of the important parameter which need to be found out. Okay, now to find the pitch, as I said, we'll be using the optimum center distance equation. For that, this equation also you can find it from page number 7.74. Okay. Now the equation is something like this: a is equal to 30 to 50 into p, pitch. Okay, now, as per the question, your center distance was already given. A value is 500. So you can find the maximum value and minimum value, right? Now, if you divide 500 with 30, you will be getting maximum P max value. And if you divide it by 50, you will get the minimum value. Okay. So your pitch value actually ranges between, you can take any value between 10 and 16.6. Okay, so any value is fine. The only thing is that the strength and bearing pressure should be within the limit. If not, you need to select another value. Okay, now here let us take the value as 15.875, which is actually a standard value. Okay, I'll show you how this standard value is taken. Okay, for that you need to go to page number 7.74. Okay, so you can see from here in this page number, the optimal center distance equation, you can find it from here. See, as of now, all the steps are here. The first step was to find the transmission ratio. Second step, from the transmission ratio, you need to select the number of teeth. Then find the other number of teeth using set 2. And once you have found that, you can find the number of pitch using the relationship given in the same page. Okay, sorry, not the number of pitch. It's a pitch value, right? Now, using this relationship 30 to 50p. Now, once you find the pitch, actually these three are the standard pitch values. Okay, that is 9.525, 12.7 and 15.875 are the standard value. Okay, now in this question we have already got the range as in between 10 to 16, right? 10 to 16 is actually the range. Okay, so you need to neglect this value. 9 cannot be taken. So you can take any standard value between 12.7 and 15.875. Not any other value, because based on this only we will be selecting the chain drive, type of chain. Okay, so the pitch should be selected appropriately. Okay, so either you can select 12.7 or 15.875. Okay, 9.525 cannot be taken because the range is above this value, right? So let me take the value as 15.875. Okay, by taking this value, let us continue our procedure. Okay, so P value is taken as 15.875. Okay, that is the standard value, right? Now, once this value has been found out, the next step is to select the type of chain. As I said, the type of chain is selected. One of the parameter which is used for selecting the standard chain is your pitch value. So once the pitch is found out, you can select the chain. Now, from the design procedure itself, we have seen that you can either select a simplex chain or a duplex chain. Okay, so now what does this mean by simplex or duplex means? Simplex means you will have only uh, one set of chain links. Okay, not the chain links, the projection in which the chain link is held. Okay, and that means okay, right. So duplex chain means there will be two. Okay, duplex means there will be three. Right. You can see that also in your data book page. Right now I don't have that figure. Okay. Now let us see how this is selected. Now here the selected one was 10A2 DR50 has been selected. We'll see how it is selected. So let us go to page number 7.72. Okay, 7.72. Okay. Okay, so this is your page number 7.72. So in this page you can see you need to select the selection should be purely based upon the pitch value. Okay, so these are 12.7 values. From here your 15 point value starts. So we have selected 15 point value, right? So as I said, we will be selecting duplex values, right? Duplex chains. Okay, so DR actually represents duplex chain. No need of any confusions. There is one more page there is one more page in 7.71. The notation, standard notations are actually given, okay, which says what is dr, what is tr, and all. Okay, so we are selecting duplex chain. Since it is duplex chain with pitch 15.875, let us select this value, okay, dr50 for 15.585 pitch and duplex dr is actually representing duplex. So dr50 1082 dr50 is the chain that we are going to select. Okay, so it is purely based on the pitch value, and we have selected duplex. Okay, if it was simplex means we'll select some other one, right? So this is the particular type of chain that we are going to select. Okay, now there are different parameters. You can see from the table there are different values. For example, the roller diameter, the inner width, etc., and the maximum braking load. We'll need that in future. Okay, so just now make a note of this, this value. Okay, maximum braking load, all these things will take, and the braking area, you can see the braking area 1.40 centimeter square, and all these are the values corresponding to this chain, right? So the chain that we are going to select. Okay, so depending upon the pitch and the duplex condition, we are actually selecting the chain. Okay, so the selected chain, as you can see, is 1082 dr50 we are selecting. Okay, you can select anyone. The only thing is that you need to say what it is. Either you must either select a duplex or a simplex chain. Okay, and the only thing you need to match with the pitch. Okay, so after selecting a duplex chain, the next step is to find the total load acting on the driving side of the chain. Okay, total load acting on the driving side of the chain. So for the total load acting on the driving is given by this equation, PT plus PC plus PS. Okay, so this equation you can see in page number 7.78 to 7.78. Okay, so for the total load is equal to tangential force PT plus centrifugal force PC plus tension due to sagging. It's a combination of these three forces. Okay, now for that, to find these values, you can directly go to page number 7.78. Okay, so in page number 7.78, see here you can see the equation, that is P is equal to PT plus PC plus PS, and that PT value or the tangential force can be found out using this equation. So in your data book, the value will be 102 N divided by V, but it is actually 1020 Newton in N divided by V is the, so make the necessary correction. You need to multiply 1020 into N divided by V. Okay, and similarly centrifugal value also you can find it from here, W into V square by G, and PS value also you can get it from the same page. Okay, so the tangential force, as I said, it is 1020 into RPM divided by velocity. Okay, now here there is a change in the velocity equation, and the velocity equation is given by number of teeth into pitch into RPM divided by 60 into 1000, and this equation is not there in your data book. You must remember this equation for solving in your final examination, right? So the tangential force is equal to 1020 N divided by V. Okay, upon substituting those values, you will get PT as 17,748 Newton. Okay, so once that value is found out, you can find the centrifugal load, okay, which is given by weight into V square by G. Since it is weight by G, you can substitute as mass, okay, mv square. On substituting the value, you will get it as 78 Newton. Okay, similarly, tension due to sagging is given by kWA, where W is the weight, K is actually a constant. Okay, I'll show you how to find the constant. A value is actually the center distance, 0.5, and center distance in meters actually, right? You need to convert that 500 mm value to meter, that is nothing but 0.5 meter. Okay, now I'll show you how this K value is selected. For that, again go to page number 7.78. Okay, so you can see the K value can be selected based on these conditions. Okay, if it is horizontal chain, the K value can be taken as 6. If the chain is inclined 40 degree up to 40 degree, you can take 4. More than 40 degree means you need to take 2, and if it is vertically kept means you need to take K value as 1. Okay, now here let us take it as horizontal, and since it is not exactly the question does not speak exactly which condition it is held, so you can take horizontal. Let us proceed with the horizontal alignment and take k value as 6. Okay, so upon substituting the value as 6, you can get the sagging value as well. Okay, now substitute all those values and you will get the total load. Okay, and the total load is 1876.4 Newton. Okay, so we have completed the we have already found the total load. Now once we get the total load, the next next step is to find the design load. Okay, it is actually the total load acting on total load. We have already found out the total load acting on the driving part, right? Now it is actually a theoretical value. Okay, now there will be different parameters which are affecting this load and all, right? So to be on safe side, you need to let us find the design load which is a higher value, right? Now to find that value, we will be multiplying this design load with a constant which is ks. Okay, and that ks is a combination of these many constants. Okay, and this equation is not given, but it's very easy to remember, right? Because you are actually to find the design load, only thing that you are going to do is you are multiplying it with a constant ks. Okay, now to find this ks, you need to find all these 6 parameters. Okay, and all these parameters you'll get it from page number 7.76 and 7.77. Okay, so here the k1 is selected as 1.25 for the condition that is variable load and mile shop. So we'll see how it is selected. So this is your page. Okay, so you can see the service factor equation is given over here. The first condition is load factor K1. You can select it for constant load, variable load with mild shock, variable load with heavy shock and all. Okay. Since nothing is said in the question, you can take any of the value and just mention the condition which we are selecting. Okay. Similarly, all other parameters also you can select depending upon the conditions. Okay, so if the condition is given, you should follow the condition. For example, for selecting K3, there are 3 conditions. Okay, but here actually we have used this equation for finding the pitch, that is 30 to 50 pitch. The A is equal to 30 to 50 pitch. So in this case, it is mandatory to select this value as 1. Okay, there is no other go. You need to select this one. For other cases, since nothing is given in the question, you can select the value of your choice. Okay, only thing is that you need to mention the condition. Okay, now if it is particularly given in the question, means you must take that value only, right? Okay, on substituting all these conditions, you will get the value of ks as 1.6. On substituting that value, the design load is obtained as 3002 Newton. So you can see the difference. The load was found to be 1000, total load was 1876, and after multiplying with the constants, you got the value as 3002 Newton. Now this is your design load. Okay, now let us try to find out the factor of safety. Okay, now factor of safety is actually the ratio of braking load to the design load. Okay, now to take the braking load value, we are taking based on the chain that we have selected. Okay, so we have selected a particular type of chain, right? We have selected a duplex chain based upon the pitch value and all, from page number 7.72. so let us go to that page. Okay, so here the one we have selected is this one, right? 10.10A2DR50 is the chain that we have selected, and if we see the value corresponding, the total braking load is given over here, right? The braking load is given, and if we extend this one, you can see that the value is 4440 kgf. It is in kgf, so that means it is 44,400 Newton is the braking load. That is a minimum braking load. There is a minimum braking load which is required to break the chain. So this much load is required to break the chain. Okay, so to find the factor of safety, we are actually dividing this braking load with design load. Okay, so once it is divided, the value is obtained as 14.79. so the factor of safety we are going to take is 14.79. okay, now here is something that you need to do. Okay, now after finding the factor of safety, we need to check whether this factor of safety is okay as per the chain drive is concerned. Okay, for that you need to go to page number 7.77. okay, so here say page number 7.77, you can see the minimum, there is a table for minimum value of factor of safety. Okay, so there is some standard for this one. there is actually a minimum value of factor safety which must be taken. Okay, so you can see the pitch that we have selected is actually 15.875. Okay, and the speed of rotation for the small sprocket as per the question is 970 something, right? So we can approximate it as 1000 rpm. Okay, now if the sprocket is running at 1000 rpm and if the sprocket is having a pitch of 15.875, the minimum factor of safety that you should take is 11. Okay, so minimum factor of safety of 11 is mandatory as far as this design is concerned. But here what we have obtained is 14, which is far above the value 11, right? So it is safe, so you can continue with the factor safety as 14 itself. It is okay. Now if suppose the value is coming below 11, for example the value which we get is 8 or something, means you need to redesign. Okay, so that's it. So the value of factor safety is fine, so that means the design is satisfactory up to this step. Okay, now the next thing is you need to check with the induced stress, the stress that might be produced in the chain with the maximum stress with the material can withstand. Okay, so that is going to be our next step. That is, we'll be finding the induced stress on the on the chain or the rollers. Okay, now to find this we'll be multiplying, we'll be using this equation, and again this equation is also not there in your data book, but it is very easy to remember this one. It is a product of tangential load, not the total load. Okay, let's make it a point. It is not the total load. It is not P into P subscript capital D. It's actually P subscript small t. Right. So it represents the tangential load. Okay. So for the induced stress is actually the product of tangential load into the Ks value, the constant value. So you need to multiply tangential load with Ks divided by the bearing area. Okay. And the area value is taken as 140 mm square. Okay, now this value also you will get it from the standard table. Okay, so we have selected 1082 dr50. Okay, now on extending this one you can see the breaking area as 1.40 centimeter square. Okay, so this value we are selecting, that means since it is in centimeter square we are converting it to millimeter square. The value comes to be 140 mm square, right? Okay, so directly substitute those values, you will get the stress, induced stress. So this is actually the stress that is getting induced, in the chain while it is transmitting that 11 kilowatt power. Okay, as per the question it is transmitting some power, right? Now since if it is transmitting that particular power, now this is the stress that will be induced, that is a maximum stress that will be formed in the chain. Okay, so for a design to be safe, the maximum allowable stress should be greater than the induced stress, otherwise it is not safe, right? So you need to check that also, right? The maximum stress that the material can withstand also you should check, right? Now for that you need to go to page number 7.77. okay, so if you go to page number 7.77, again just below that that factor of safety value which we have taken in the previous step, you can see here the allowable bearing stress. Okay, the allowable bearing stress value is taken again with respect to your pitch and speed of rotation. So we have taken 1000 as the speed of rotation because it is given in the question as 970. Okay, the nearest value is 1000, so we are taking 1000, and the pitch we have selected is 15.875. Now this table is common for all the pitches, right? Now since the rotation is above is around 1000, the stress must be 2.24 kgf per mm square, right? The allowable stress is 2.24 kgf per millimeter square or 22.4 newton per 22.4 newton per mm square. Okay, so the allowable stress from the table, it is 22.4 newton per mm square as per the given conditions and all. Okay, now you can see if you compare these two values, the induced stress is less than the allowable stress. Again, this makes the design safe. Okay, so the design is safe from two points of view. One is in terms of factor safety and in terms of bearing stress. So we have checked the two conditions. Now since it is safe, we can go to the next step, that is finding the next parameter. So only one parameter we have already completed two parameters. One was the pitch. Now based on pitch we have selected the chain and we have found the selection was okay because the stress and the factor safety is within the limit. No, if it is within the limit that your design up to this one is safe. Okay. Now, so your two parameters over. The next two parameters are the length and the sprocket diameters. So in the next two steps, we will be finding the length and the sprocket diameters. Okay. So the next step is to find the length of the chain. Alright. Your length of the chain is given by this particular equation, and you can get this equation from page number 7.75. Okay. So let's go to that page. Okay. The equation is given as LP is equal to 2AP plus this one, Z1 plus Z2 by 2 plus this one. This way you can see that equation in that particular page. Okay. Now it is taking some time. I'm sorry. Let's see that. Okay. So the equation is something like this. This is a standard equation. Only one equation is there for length of chain, and for where your AP is actually A naught by P. A naught is actually the center distance divided by the pitch that we are selecting. That is standard pitch. Okay, substitute that value over here. Z1, Z2 value and all we know. On substituting, you will get the length as 114.4 mm. Okay. Now this the value should always be rounded to an even value. Okay. So approximate the value as 116 links. Okay. So this much links. The length is in the form of, we are finding the length in number of links. Okay. 116 links are required. Okay. So actually this equation is to find the length in terms of number of links. Okay. So a chain drive is made of number of links which are joined together, right? So you require actually 116 links to complete the chain. Okay. So in terms of length, if you need to find the link is having a standard pitch length, right? Now you can directly multiply the number of links with the pitch. Now if you do so, you will get the total length that is required, and the length is found to be 1.842 meters. Okay. So with this you will get the length, and finally all you need to find is the exact center distance. For that we can use this equation given in page number 7.75. Okay. Now if you use this equation, the direct equation is the E value is also given, and the M value, the standard M value equation is also given, and all these values you know that values. Okay, directly substitute those values, and finally you will be revising the center distance. Actually, as per the question, we have taken the center distance as 500 mm. As per all these design criterion, we have finally to make this design optimum, you should select a center distance of a range 512.91 mm is to be selected. Okay, so this is the exact center distance that should be selected for completing the design. Okay, so these are the basic steps. So here, okay, now once the center distance is revised, all you need to find is the diameter of the sprocket. Okay, again this equation is also given, and you can find this equation in page number 7.78. The standard equation is given. The sprocket diameter, this equation is given, but the sprocket outside radius equation is not given. You need to remember this equation. Okay, so on substituting those values, you will get the diameter of the small sprocket, diameter of the larger sprocket, and using the final equation you can find the outer diameters as well. Okay, so with this your design procedure is over. So we have found out. So let me revise this complete steps once again quickly. Okay, so the design procedure starts with determining the transmission ratio. If it is not given, you can take the value. Once that is obtained, means you can find number of teeth. Okay. Now, once you get the number of teeth, the next step is to find the number of is to find the pitch. Right. For that, you should find the maximum and minimum pitch and take the standard value of the pitch which is coming in between the range. Okay. Now, once the standard value is taken, the next step is to select the type of chain. Okay. And for that, you need to assume it's either simplex or duplex, and based on that you can select a chain corresponding to the particular pitch. So once that is selected, the next step is to find the design load. For finding the design load, you should find the total load which is acting on the driving side of the chain. Okay, for that you have a standard equation. Use the standard equation. All these equations are there in your data book. So directly substitute those values, you will get the total load. Multiply it with the service factor, If you do so, you will get the design load. Once you get the design load, find the factor of safety by dividing breaking load with the design load. The breaking load value you will be getting from the data book corresponding to the chain that you have selected. Okay, now on dividing that, you will get the factor of safety. Now comes the main important step, that is you need to check the value of factor of safety whether it is safe or not. So check the value of factor of safety. If it is safe means you can proceed with the next step, which is checking the bearing stress. Okay, again find the induced bearing stress, check it with the standard value. If it is safe means you can proceed with the by finding out the length of the chain. Okay, so using the standard equation you can find the length in terms of number of links. Once you get the number of links, you can find the actual length. Similarly, you can find the exact center distance. Okay, you can revise the exact center distance, and once you do that, find the sprocket diameters. Okay, and for all these your standard equations are there in your database. Okay, so even though step is lengthy, the procedure is simple. So do this problem with your data book, by referring your data book only. So thank you. So this is the last lecture video in this series. So thank you one and all. So study well and all the best for your exams.